Hi everybody. This is, I believe, notes number 39. Let's see if I can get my tools to work properly. There we go. The last notes we had was notes 38 on radians. And so as you can imagine, I'm going to try to keep the lessons really short and just stick to the absolute essentials. And so what we're going to look at today is the graph of three of the trig functions, the sine function, the cosine function, and the tangent function. So go ahead and get yourself ready for your notes. Hopefully you have your notebook. And we're going to have a couple of vocabulary words, period and amplitude, but I'm going to come back and define those after we look at our first graph. Okay, we're going to learn how to graph y equals sine x. So what you want to do is set up your graph. On your x-axis, you want to give yourself some space and go, we're using radians here, so you want to make a mark at pi over 2, at pi, at 3 pi over 2, and at 2 pi. You want to think of those as 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Remember that 2 pi radians is equal to 360 degrees. So basically what we have is one full time around the circle, or we're going through all four quadrants, so you could think of it that way. And then you're also going to negative 2 pi on your x-axis. And then on your y-axis, we could go ahead and put a 1 up here at this level and a negative 1 down here. Okay, here's how we find the points to plot. So you think about your exact values. So your points are going to be inputs are angles, outputs are the sines of those angles. So let's start with 0. What if your angle is 0 radians? You're right here. Remember the way we find the quadrantal angle values? That would be the point 1, 0. And so the cosine is 1 and the sine is 0. So the sine of 0 is 0. So we can plot that point on our graph. Now let's go up and do 90 degrees, but we're not going to think of it as 90 degrees, it's pi over 2 radians. And that point has coordinates 0, 1. So the cosine is 0, the sine is 1. So the sine of 90 is 1, the sine of pi over 2 radians is 1. So we can plot that point. That's the point pi over 2, comma 1. Now let's move on to pi radians, which is 180 degrees. So that would be over here at the point negative 1, 0. So the cosine is negative 1, the sine is 0. So we have the point pi 0, and we can plot that on our graph. And then let's go to 3 pi over 2, which would be 270 degrees. And that's the point 0, negative 1. So this cosine is 0, the sine is negative 1. So that gives us the point 3 pi over 2, negative 1. And then let's go to 2 pi. So 2 pi radians is coterminal with 0 radians. We're back at the start, and so we're back at the point that has x coordinate 1, y coordinate 0. So the sine of that is 0. So we're back to 2 pi comma 0. Okay, we've made it around the circle one time, one complete cycle. And what's happening in between these 5 points that were plotted? So let's think about that for a minute. So I'm going to draw on my unit circle. Imagine you had, let's say, a 20-degree angle. What is its sine? So sine is opposite over hypotenuse, and the opposite is this part, the vertical part, and the hypotenuse on the unit circle is always 1. Now what if instead of a 20-degree angle you had a 40-degree angle? What's happened to the sine? Well, the opposite side has gotten bigger while the hypotenuse is still 1, so the sine will be bigger, etc. as you go. As you make the angle bigger, the opposite side keeps getting bigger while the hypotenuse still stays the same, so you're getting larger and larger sine values until you get up to 90 degrees. So what's happening on our graph is the values are growing. It's not a line, it's a curve. And then you could follow that kind of logic throughout each quadrant, and what you're going to see is the graph goes like this. Okay, so that is one complete cycle of the sine graph. The width of one cycle is the period. So what's the width of that cycle? It went from 0 to 2 pi. So the width of that cycle is 2 pi. So therefore the period is 2 pi. The amplitude is the distance from the middle to the top. So you could think of the middle being at a height of 0 and the top being at a height of 1. So the amplitude is 1. Another way to think of amplitude is half the total range. And you could also think of it, oh, there's a third way. You could take the top minus the bottom and divide it by 2. Okay, so now let's go back and define amplitude and period. So period, the width of one cycle. And amplitude, we can define this in several ways. So distance from middle to top is what I usually like to use. It's also distance from middle to bottom. Just absolute value, always positive. Amplitude is always positive. You could think of it as half the total range, which is the same as half the top minus the bottom. Okay, now let's go back to the graph. So I just drew one complete cycle, but as you know, you could keep going around the circle over and over and over, and you would have more of these curves. So you could keep going and you would have another one and another one and another one. So we're going to draw this graph, another cycle on the left side of the one we just drew. So what you're going to see is another point at negative pi over 2, negative 1, another point at negative pi 0, another point at negative 3 pi over 2, 1, and another point down there at negative 2 pi 0. So you're just going to see a repeat of this pattern over and over again. It's like wallpaper. Repeat the pattern. You could start anywhere you're asked to start. You could end anywhere you're asked to end. You're just going to repeat that pattern. So that is what the sine graph looks like. And how many periods of this, how many cycles do you see? I see 2 full cycles, and the width of 2 full cycles would be 4 pi, because the width of one cycle is 2 pi. Okay, let's go ahead and look at the graph of y equals cosine x. So we can do the same idea, where we're going to start with an x value of 0 and find its y value. Its y value is the cosine value. If x is 0, here's the point 1, 0. The cosine of 0 is 1. If x is pi over 2, that would be 90 degrees. The cosine of pi over 2 is 0. If x is pi, that would be 180 degrees. The cosine is negative 1. If x is 3 pi over 2, that would be, sorry, this is not the best tool. That would have coordinates 0, negative 1, so the cosine of that is 0. And if x is 2 pi, now we're back up to 0 again, so the cosine of that is 1. So let's plot these points. 0, 1. Well, let me mark my axes. There's a 1 up there. If you need to pause and draw your graph, go ahead and do that. Make your markings on the x-axis just like we did for the previous graph. Okay, now I'll plot my points. I have 0, 1, and I have pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. And then we connect those, and we get one cycle of the cosine graph. And that would repeat over and over and over. So we could show another cycle on the other side. So we're at the point 0, 1, and then we can go down to a height of 0, down to a height of negative 1, back up to a height of 0, and back up to a height of 1. And connect those with a smooth curve. Make sure your curve is smooth and not pointy. It's curvy, not pointy. Okay, that's what cosine looks like. So what is the period? What's the width of one cycle? One cycle goes from 0 to 2 pi in this case. That's how I kind of started it. So the period would be 2 pi, the width of one cycle. Now note, you could start it anywhere you want. Like if I start it here and go a width of 2 pi, it ends there. That's still one complete cycle. So one complete cycle will always have a width of 2 pi. And what's the amplitude? So what's the distance from the middle to the top? It's 1, just like it was for the sine graph. Now, here's how I think about the differences between the sine graph and the cosine graph. So the sine graph, I say it starts at 0 because it goes through the point 0, 0. I'm thinking of the start being at the y-axis. And for the cosine graph, I say it starts at 1, and that means it's at the point 0, 1. Or you could say it starts at the top. It's like a roller coaster and you're starting at the top. For the sine graph, you could say it starts in the middle. So just various ways to think of it so that you can remember the differences between the two. All right, moving on. Let's take a look at the tangent graph. So let's start the same way. We're going to find some points to plot. Let's do 0 and pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so pause if you need to, draw your graph, get everything labeled and ready to go. And again, I'm going to put 1 on my y-axis, 1 and -1 there. Okay, and then using the unit circle for 0 radians, here we are at the point 1, 0. The cosine is 1, the sine is 0. Remember, to get the tangent, you do sine over cosine. So y-coordinate over x-coordinate would be 0 over 1, and that's 0. For pi over 2, we're at the point 0, 1. Sine over cosine, y over x would be undefined. For pi, we're here at 180 degrees, -1, 0. We have sine over cosine, y over x would be 0 over -1, so that's 0. And then here we are at 3 pi over 2, that would be 270 degrees with the point 0, -1. And so y over x would be -1 over 0, so that would be undefined. And then back to 2 pi, we're back to the point 1, 0. So y over x would be 0 over 1, and that would be 0. Here's how we deal with the undefineds when we graph a tangent graph. Everywhere you see an undefined, you're going to have a vertical asymptote. So we can put those in place. Vertical asymptote at pi over 2, vertical asymptote at 3 pi over 2. Okay, these vertical asymptotes are pi units apart. So we could put others in place as well. Every pi units, we're going to have another vertical asymptote. So there's one at x equals -pi over 2. There's one at x equals -3 pi over 2. And if we were to keep going beyond what we're doing here, we would just continue to have infinitely many vertical asymptotes. Okay, now we can plot the other points. We had the point 0, 0. We had the point pi 0, 2 pi 0. So you're going to see there's a pattern. Halfway between each set of asymptotes, you have a 0. Now what's going to happen, and I don't have time to go into this in a lot of detail, but what's going to happen as you move from, say, 0 radians up to pi over 2 radians. So as your angle gets bigger and you're going from 0 degrees to 90 degrees, what's going to happen is if you think of tangent as the ratio of opposite over adjacent, the opposite keeps getting bigger and bigger while the adjacent keeps getting smaller and smaller, and that's just going to keep happening to the extreme, and so your values are just going to keep going up and up and up and up. So, and then when we get to when we're in quadrant 4, they're going to be doing the same thing, but they'll be negative. So that ends up looking like this. That's what a tangent curve looks like. And that curve repeats between every two asymptotes. We have a curve that looks just like that. So you can fill those in. Now, if your plan is to stop at 2 pi and only show to 2 pi, then what you'll do is you'll fill in half a curve and leave it like that. And on the other side, if your plan is to stop at -2 pi, you're just going to have half a curve like that. So sometimes you're asked to just graph a particular amount and not go beyond it. Like right now, we're not going beyond negative 2 pi and we're not going beyond 2 pi, so we'll just stop at those points. So that's what your tangent graph looks like. What is the period? So what's the width of one cycle? One of those wallpaper patterns that you see repeated over and over. Notice that it's just pi. The period is just pi because the pattern repeats every pi units. And what is the amplitude? So what is the distance from the middle to the top? There is no top. It keeps going up toward infinity. So we say the amplitude is undefined. Okay. Now, what I want us to do is practice graphing each of these again. So I'm going to show you my shortcuts. Now that we have an idea for what these are supposed to look like, I'm going to show you my shortcuts. And this time I've decided we're going to graph on the interval from 0 to 2 pi. So here's how you want to think through this process. Draw your graph, and we're going out to 4 pi. Put a 1 and put a negative 1 on your y-axis because we know it goes up to a height of 1, it goes down to a height of negative 1, and that's it. That's all you need. Next, you know that the period is 2 pi. So let's break this up in widths of 2 pi. So right between 0 and 4 pi, I'm going to put a 2 pi. Now, if you look back at the previous sine graph we drew, notice that it's kind of broken into 4 chunks. We have it's going up, it's going down, it's going down, it's going up. So let's break our period into 4 chunks. So between 0 and 2 pi, cut it in half, cut each half in half. Now you have 4 chunks. Between 2 pi and 4 pi, cut it in half, cut each half in half. Now you have 4 chunks. And remember that the sign of 0 is 0. So it's going to start at 0. So you put a point at 0, 0. Then you go up to the top, back to the middle, down to the bottom, back to the middle. Up to the top, down to the middle, back to the bottom, back to the middle. And then you connect those. Smooth and curvy, not pointy or straight. All right, that's how you do that quickly and easily. Let's practice for the cosine graph. Okay, once again, you know the period is 2 pi. You're going to make your axes, and you're going out to 4 pi. You go up to 1 and down to negative 1. Because the period is 2 pi, you want increments of 2 pi on your x-axis. And then the cosine graph you could think of as also splitting into 4 chunks. So you start at the top, you go down to the middle, you go down to the bottom, you go up to the middle, and up to the top. Those are your 4 chunks. So we need to split the interval from 0 to 2 pi into 4 chunks. Split it in half, split that half in half, split all the halves in half. And then from 2 pi to 4 pi, split that in half, split those halves in half. So here we go. Remember that cosine of 0 is 1. That means it's going to go through 0, 1. And so I say we start at the top. We're at the top of the roller coaster. So you put that point in place at the top. So from top to middle to bottom to middle to top, go again, to middle to bottom to middle to top. Connect. Whoa, I kind of missed there. Connect with a smooth curve, not pointy or straight. Notice how it curves toward the end like it's about to go back down. Make sure you curve it there as well. Okay, and now let's practice graphing the tangent graph. So we're doing this also on the interval from 0 to 4 pi. That's just because that's what I chose. It could be any interval. Let's split that up. But remember that the period of tangent is 1 pi, not 2 pi. So we want to break this up more. There's pi, there's 3 pi, and then break those up into chunks as well. Now remember that the tangent of 0 is 0. So you could say that this one also starts at the middle. So what you want to do is put your zeros in place and then your asymptotes in place. A zero, an asymptote. A zero, an asymptote. A zero, an asymptote. Do that until you get to where you're told to stop. We're told to start at 0 and stop at 4 pi. And now you put those curves in place, tangent curves. Have fun with it. They're kind of fun to draw. Now, because I started at 0, I only have half a curve on the left, and because I'm ending at 4 pi, I only have half a curve at on the right. Whew, trying to speak fast because I know it's been 20 minutes already. Okay, here's what I want you to do. I want you to practice graphing these, and so I'm asking you to do it twice, and I've given you different intervals for each problem just so you can practice going from one starting point to another starting point. See if you can do it without looking at your notes. Obviously that might take some practice, but I encourage you to use that idea of breaking them down into chunks and doing the thing where you do middle, top, middle, bottom, middle, things like that. That's really helpful to me. Thanks, everybody.